Let us consider another example in which null hypothesis and alternative hypothesis is given. Just write down what is given. Hypothesis is H naught, that is null hypothesis mu equal 20. Alternative hypothesis HA is mu less than 20. Okay. Now mu equal 20, mu less than 20. So this is one-tailed hypothesis, or we can say one-tailed test. And since it is less than, it is left-tailed. Okay, by the definition of hypothesis. Now let us read out what else is given. A sample of 50 provided a sample mean of 19.4. Now they are talking about sample. So what information we have from sample? Sample of 50, that is the size of sample, which we denote by n. It is given by, which is equal to 50, and sample mean, which we denote by x bar, is equal to 19.4. Okay, what else is given? The population standard deviation is 2. Now they are talking about population. So as we know that from null hypothesis, this mu represents the mean of population. Mu, which is equal to 20, the population mean. Also from here it is given standard deviation of population. The standard deviation of population, which we denote by sigma, it is equal to 2. Okay, so we have these information. So now for population we have mean and standard deviation, while for sample we know only mean. So by the condition of test, since for population we have mean and standard deviation, we will apply z-test. So what we have to do now next is to calculate the z-value. Z-value, it is given by the formula x bar minus mu divide sigma over square root of n. Okay, we have all these values of x bar, mu, sigma and n. So substitute it over here. What we will get? We will get x bar is 19.4 minus mu 20 divided by sigma. Sigma is 2 divide root of 50. So if we calculate it, it comes out to be minus 2.1213, which is a negative value. Okay. Now part B, alpha equal to 0.01, what is your conclusion? So it means they are talking about our decision. So for that, first we need to find the critical region. Critical region where level of significance alpha is given to be 0.01, that is 1%. Now from the table, now since we notice that this is a which tail? One tail test, that is left tail. So for one tail test, we look for alpha 0.01. One tail test, the z value is from the table is 2.33. So z value from table is 2.33. Okay, now let's see from this table. One tail test, when it is left tail test, the critical region is z less than equal to minus z temp. So for this, the critical region is z less than equal to minus z tabulated. That is, z is less than equal to minus 2.33. Okay, that is, if we try to draw it, whatever critical region, if suppose this is the point minus 2, minus 1, 0, and we say this is say minus 2.5. So z point minus 2.33, minus 2.33. Suppose it comes outward here. So our critical region is the region which is less than 2.33, means all this thing is critical region. Okay, up to minus infinity. Now we have, so what this critical region means, if the value of z that we calculated by calculation, that is this value, if this value lies in the critical region, we will reject the hypothesis, otherwise we will accept it. Now our z value, z calculated value, how much it is? Minus 2.1213, right? If we plot it on the number line, where it comes? Here, somewhere here. This value, it not lies in the critical region. We can see it from here. So this value not lies in critical region. In the critical region. So what this implies? Our null hypothesis H naught, we have to accept it. We accept it. That is, we accept H naught. That means, what is the null hypothesis? The null hypothesis is that mu is equal to 20. So this means that mu is equal to 20. Okay, clear?